In this video we're going to explore how to turn your Netduino Plus into a Modbus RTU over TCP/IP device. I'm going to give you first a demonstration of all the things that it can do, and then we're going to go into detail on how you can do it too. So for starters, we just have a Netduino Plus. This is the first generation, not the second. It's getting power from the USB, and we've got Ethernet hooked up. I have this little shield I built. Basically what it has is switches to simulate discrete inputs, some LEDs to show us the discrete outputs, and then some potentiometers we can turn to change the analogs. And then I have an HMI here that it's called ScadaBR. It's a free one. The website's in Portuguese, so it's a little daunting at first, but there's help out there, and ScadaBR is a completely free HMI system that you can use. So, and it basically will run on any web browser. This is a Windows tablet, but you could use a Android tablet, phone, whatever. Okay, so without further ado, my discrete outs, you can turn them on here. Notice these lights, very responsive. Okay, so my discretes, these are coming from the Netduino to the host system. I'm just turning them on one by one. So there's number 2. I'm going to skip to 6. So anyway, you get the idea. And then our analogs, this first value here, crank it up about halfway. So I'm going to do number 3. And then number 4. Oops. Anyway, 5 and 6 are actually tied to this last one, so you'll see them both be kind of similar. Then number 2 as well. So we're using a Modbus protocol on the Netduino, and it's Modbus slave. So there's a master, and actually my master's on this little Atom laptop, and it will pull the Netduino. This is where you set up the data source. Okay, so we've got these points set up, and there's registers. So my analogs are input registers, and it's 0 through 5, and then my discrete inputs are input statuses. DO is called coil statuses. This is what it's called in Modbus. So input register, input status, coil status, and so forth. So you might not know much about Modbus, so here's a very quick crash course in what we're doing here. So I have some industrial software here that can actually show the hex. This is the data going out and returning. Blue is the transmit line, as you can see, TX. Then RX is the green. That's what comes back from the Netduino. So over here it shows what items I am asking the device for. This is not something you guys need to know. So we have our coils. So Modbus, we're asking for registers 1 through 4. Those are the coils. Those are the things that we can write to. Netduino down here, I'm going to write to one of these real quick. I'm going to write a fault switch is off, and you'll see that one, number 1, just went off. Watch closely to number 2. Sync right, nope, sync right, off. Okay. And then we have our input statuses. It's going into the Netduino, so they're all on right now. I'm just going to turn some off And then of course our analog values or input registers. So I'm going to turn most of them way down. You'll see those values update here. So Modbus has been around for a very long time, so it's not the most modern protocol, but it is pretty solid. There are, you know, thousands, tens of thousands of different types of devices out there that can communicate Modbus in the industrial world. So anyway, we're asking for 3 different kinds of data here. There's the coils, the digital statuses, and the analog statuses. Let me go ahead and clear this, and I'm going to pause it. So about every 5 seconds this master program on my laptop goes out and queries the slave, which is the Netduino, and there are 3 different transactions. The Netduino's address is actually 5, so you see this. I'm not really quite sure what this garbage is in the front, some kind of checking, but anyway, 05 is the address of the device. We send it a function code, a Modbus function code. 01 says read the discrete output coils, which is these guys right here. Notice there's 4 of them. And then it says, how many do I want? Give me 4. So we simply ask for the data, and then it sends us back the statuses. And then the next message we say, hey, number 5, wake up and give me number 2. So that is, we want to read the discrete input contacts, and it says give me 6 of them. Same thing here. This is a function code 4, which is read analog input registers. So it's very cool, very simple. You just have different addresses of devices. So you can have, in general, you normally can have about 254 devices on the same serial network. This is TCP/IP. Each device is going to have its own IP address, so there's no limit there. But on a serial network, you can have address 1 through 254. Usually you skip 1, so about 253 devices. You send it a function code. You tell it how many of the things you want. Pretty slick. Alright, I apologize. I'm not going to do a screen capture. I'm a little lazy today, so I'm going to aim the computer at the screen here. So, specifically, my Netduino Plus, it's a Netduino Plus 1, not the very latest and greatest, which is a Netduino Plus 2. So, my experiences may be a little bit different than yours if you're trying to do this yourself. The firmware is critical as well, because with different versions of firmware, your program's going to maybe look a little bit different. The firmware in my Netduino Plus is 4.2.0.1. I believe that's the last version that's going to be on the Plus 1. They're now focusing on the Plus 2. So where to get this cool program? Well, do a search for Netduino Modbus. This library I am using, it's from a guy named Mario, and he's gone to a lot of work to build this Modbus library for Netduino. It is Modbus, TCP and UDP, also serial, so it can be a master or a slave. So very cool Netduino library. You can read through this, his site here. His website is highfieldtales.wordpress.com. So, let's go ahead and go down and get this thing. Towards the bottom, he says software is in Codeplex. So, in Codeplex, setdevelop.codeplex.com. So source code, since anything you downloaded would be source code. You can see he has an older version and this newer version, which is what I suggest. So you go ahead and do a download, save. Alright, and I suggest that whenever you save it, You go ahead and extract it and go into your Visual Studio 2010, which is, I believe, what you really need to use for a Netduino right now. I'm not sure that you can safely use a newer version. So your Visual Studio 2010 projects. Actually, I just went and downloaded a brand new one, extracted a brand new one. That way we can walk through all of the things I had to do to get it to work. So there's version 1, version 2. Version 2 is his latest that he's been working on. Just kind of browsed in here until I found, usually he has one that's called the demo or the test, and that's where he's kind of has it set up ready to go. So if you're on Micro Framework 4.2 right here, here's the solution in C#. Okay. So your main program in a Netduino is usually program.cs. And I'm assuming if you're going to go ahead and do this that you've already done some initial testing with your Netduino. You've done the button blink, you've played around a little bit with it. This is a little ambitious to be the first project you ever build on your Netduino. But anyway, so notice that the device address is 5. You can change that from 1 to 254. As you can tell, I left mine 5. And then you go ahead and set up your IP address. So with IntelliSense, you hover over there, it'll tell you that we have IP address, subnet, and gateway. So, alright, so my network is 10. I chose to do, whoops, IP address 220, subnet's good. This is my gateway. Alright, so that's all done. The other thing I have to go do is notice that things like if slave RTU, and then we've got all this code that's kind of minimized. If master TCP, if master UDP, and this stuff is minimized. Well, the reason that all works is up here. Notice he has defined, this is where you select what you would like to do. So master TCP is what he has going on. If we go down, you'll see master TCP is the code that's going to be used, and a lot of this other stuff is minimized. So right now I am not going to do that. So obviously with a master, your Netduino is actually going to be pulling data from another Modbus device. It could be a Netduino, it could be anything. Now the slaves, masters are basically like a server, and slaves are like clients. The slaves are out in the field. They're sitting there just waiting for someone to ask them for data. So I want to do Modbus slave over TCP IP. This one is probably serial. This is UDP over IP protocol. We can minimize that. Okay, slave TCP, pretty simple stuff. You can see he's got a lot of work has gone over here into the libraries, the codecs, protocol, the handling all this. What you would normally do is just build the solution, yay, and then you can just hit debug, which writes the program to your Netduino. Down here it's preparing to deploy. Alright, so there's some deployment errors. Device not found. Okay, so we're going to start knocking some things out. So what you need to do is go to this project that we're working on. This was program.cs. We'll go into this main project, properties. make sure our framework is right. Go down here and we're going to switch to serial back to USB to get rid of a little bug. And then there should be a Netduino there. Let me unplug and replug this Netduino, and there, it's found it. But you might need to switch from serial to USB to fix a little bug, so go ahead and do that. Save all. Gonna try it again. Alright, so this one ate my lunch for a couple hours. It's kind of random. It's like this project. If we go up to the, it needs to be of type console or class, blah blah blah. So if you go up here, it is a console application, blah blah blah. Well, the underlying reason is there are a lot of projects in here, and you need to select this main project with the program CS and say, I want this to be the startup project. Alright, build. Okay, it actually did send it out to the Netduino. I've gotten this one a couple times. I really don't care. I just say continue and stop debugging. Now if it doesn't communicate, you might go ahead and just hit the reset button under there. Looks like it is communicating. I have a few issues. For one, the analogs are all 0. If I crank one of these all the way up, it actually, I think it'll go to 1. Yeah, so it actually gives you some kind of feedback that it's working. Now, this is probably not going to be an issue on a Netduino Plus version 2. I'm just assuming. I'm guessing. I don't have one. So that's one issue. The other issue is that all of these discretes are on, and I hit these switches and they all stay on. So there was some troubleshooting to figure out why this stuff wasn't working. Once again, the only thing I'm ever editing is this program.cs. Alright, so here's where we set up all of the I/O. And since I have this handy little shield already built, my I/O is in a little bit different order than theirs. So I'm going to go ahead and reorder the I/O and so that it works with this little shield. Notice 1 and 2, I never used 1 and 2. He's actually using it, but 1 and 2 is often used for serial communication on an Arduino or even a Netduino, so I never use those two. So I only have 4 analog outputs. He has 6 here. So obviously you can mix and match the I/O as you see fit, but I'm going to get it working for this shield. I actually have a video showing how to build one of these, so if you're not interested. Okay, so the issue I was having where everything was on and didn't turn off was these pull-up resistors. And just to show you what you can do, you can go back here, put a dot, and you can have it pull up or pull down. For my situation, the best way to get everything working was to be disabled. So the I/O is floating. If it's disabled, it's just going to float. It can actually turn on and off all by itself. So I've actually got this little black thing in here is a resistor array. So it's like a 10K resistor on each pin to power. So it's pulling it up high, and then whenever you switch these, it just shorts it to ground. Like I said, I don't want to have this many of them, so I am going to get rid of 6 and 7. So So now when I ask for 0, I actually want to start at 2. And then the coils, I only have 4 of them. And when I ask for 0, I actually want to do 8 and 9, which is good. And then I want 12, 13. The reason I do that is I'm usually using 8, 9, 12, and 13 for these. 10 and 11 can be pulse width modulation outputs on an Arduino. So these are actually analog outputs. Just specific to my application here. And then we've got our 6 inputs there. So the analog inputs are a harder one. Like I said, I believe this might work for a Netduino Plus 2. But for mine, this does not work. So there's a few things I did. I went up here. Notice here are all of the libraries we're using. References. If we look in here, we have Secret Labs, hardware.netduino. We don't even have a hardware.netduino Plus. I'm not sure if this is necessary, but I did it and it got everything working. So I'm gonna say, hey, I want this Netduino Plus. I also need to add Secret Labs, by the way. Those are the guys that make the Netduino. I also need hardware.analog input, and this is the way I got it to actually work. So analog input. Alright, so this analog input, guys, is necessary for what I'm going to do to fix this down here. Notice that since I added this Secret Labs hardware analog input, it's ambiguous. That means there's more than one library we're using, more than one reference, that has a thing called analog input. So we have to be specific about which one we're going to use. We're going to do Secret Labs. I'm just hitting tab when it gives me what I want. Net microframework dot hardware dot analog input, and we reference this a little differently. We're going to do pins dot GPIO. There's the first one. Okay, we need to fix this guy up here, so we need to do the same thing up here. What's angry here? Yeah, we're gonna go up here and say stop using that guy. Let's just do Netduino Plus. Alright. So you can see I have some typing to do. I'm going to copy and paste. They're all happy. You could do a build. Oh man. It's not a namespace. Maybe I should not have added that. I'm going to double click that. So there's one more place where I need to add this. Let's do Secret Labs .net .hardware .analog input. Maybe you saw this where I messed up and copy and pasted a extra line in there. That's not good. Let's get it in the Netduino. Let's look at ScadaBR. I'm going to put this Modbus TCP IP data source back in service. We can go to the watch list, where you can add all these points and watch them. Notice there's a lot of zeros there. If I start turning these discrete inputs on, turn the first 3 of them on here, and then I imagine I can write to these. There we go. Yeah, come on. 1, enter. It's on now. So ScadaBR, pretty cool free program. In this data source, I'm just going to show you. I have some other videos existing and up and coming on my home automation system that's probably going to be done with ScadaBR. All I did was name this data source, tell it how fast I want it to update, put in an IP address and a port. 502 is the most commonly used port for Modbus. I like turning, if you have exceptions, I like to turn those down so it's not alarming all the time. And then if you want to add something, you just click add button here. We call it something. Remember, our slave address was 5. We can get a coil status or an input status, input register, holding register. It'd be really cool if he would add that to this library. Holding register is an analog value, but it's an output. It can be settable. Input registers are usually just like live data coming in. But if you did want an input register, you pick a data type and an offset. So starting with the very first register, that would be 0, second would be 1, and so forth. So you can see how I've set up the inputs here, starting with, they're all slave 5, but here's the offset 0, 1, 2, 3, 4, 5. So instead of, you can see in my old program, I would have actually typed in 30,001 here, 30,002. But with ScadaBR, you just tell it this much, and it knows what function code to use and so forth. So, and then of course, if you want to build a screen graphical view here, you see that I only have one screen right here called Netduino. And if I want to edit this guy, I can simply add a graphic. So let's do an analog graphic. Let's try something cool. So analog graphic, this button will add it. So it's added down here. We'll select a point. How about analog input 1? And then we edit the graphical port. Okay, so an Arduino or a Netduino, the analog value is going to be between 0 and 1023. So max range is 1023, minimum range is 0. This is how the graphic knows to scale properly. Let's do the thermometer is kind of cool. Alright, so now if I adjust analog 1 down a little bit, come on, there we go. Let's see how that updates. And then we can add a graphic. Let's, oops, nope, go away. I want a discrete or a binary, whatever. Alright, so there's a binary graphic. Let's attach it to DI1. Of course, this is what I've called it. There's the data source name, and then I called it DI1, digital input 1. And then I say image set. I want, there's a fan. Nah. Is there a pump? Bomba. Okay, so bomba must be a pump in Portuguese. So when it's a 0, we want it to say it's not running. When it's a 1, it's running. So now we've got our pump on the screen. I'm going to turn it off. DI1 is going to turn off. Go ahead and save the graphic. And that's what it looks like.